The whole basis of life is because of energy. The history of civilization is the history of energy. There is a direct relationship between economic development and energy. Rise of wealth in modern civilization is rise in energy utilization and production. Consequently, the poverty of developing countries is due to the lack of energy availability. Not only is the energy availability important, but also the quality of energy that is available is also very important, especially in rural India. Only about 60% of total energy is consumed in rural India. Yet, the quality of life is very poor because the energy available is mostly in the form of power from the muscle, that is, low quality energy. How to improve the quality of life of rural India? By generating enough energy in high quality form, that is important, is the central theme of an innovative private research institute called Nimbkar Agricultural Research Institute at Phaltan. There is no doubt that only by the generation of energy and consequently by the generation of wealth in the countryside, the rural area, that poverty of rural India can be removed. It is therefore essential to break down the economic, cultural, social and institutional barriers that impede any technical change or bring about a technical change in the rural areas of developing countries. The success story of a technical cooperation between an enthusiastic, highly trained young group of scientists, engineers, technicians and agriculturists led by an innovative and bright young man is worth applauding, and more than that, emulating. The leader of this enthusiastic group of research workers is Dr. Anil Rajavamshe. He is here with us today. Anil did his engineering education in the IIT Kanpur in 1972 and left for the United States, the University of Florida, to do his advanced training in mechanical engineering. He did a lot of work there in solar energy and other forms of renewable energy sources. For 7 years he worked there. There are many Indians in America who are working in this manner. But Anil decided to return to India and he established at Phaltan a rural energy school or research institute. And that is the good point about Dr. Anil Rajavamshe. Anil, you decided to come to Phaltan for whatever reason.
Yes.
But did you take any energy survey, survey of the needs of the people in Phaltan area?
Yes, in fact, when we started the work on energy for rural India and rural Maharashtra, the first thing that we wanted to know that what are the areas in which we should tackle this problem and what research areas we should identify. So the choice of problems had to be known, and for that we decided that the best thing to do is to take a rural energy survey,
Right.
which is what we did in for Phaltan Taluka. And the reason for that was that we felt that rather than taking villages as a separate entity, Taluka becomes an extremely important
Yes.
point,
Yes.
because all the villages are connected to a Taluka center and economical and other infrastructure already exists in Taluka areas, and we felt that if we can solve the problems of the Taluka energy wise, then we have taken care of all the surrounding villages.
Right. But what kind of energy survey did you do? What is maybe lighting or?
Okay, so the thing was that ultimately in this analysis of renewable energy versus other energy, the idea is that first of all, how much can we take care of the existing energy
Right.
by renewable energy.
Right.
So we thought that if we can take care of majority of non-renewable energy
Yes.
by the renewable energy, then that will be a first step in the right direction.
Right.
So we took the survey only for the non-renewable energies
Right.
that is being used by Phaltan Taluka.
Uh-huh.
So we took the survey for all the electricity requirement
I see.
in lighting, pumping and
I
some
see.
industries. Then we took the energy survey for all the cooking via kerosene, via LPG gas. In fact, it's very surprising that the survey came out that in rural areas, because of the availability of gas, there are a lot of people who are converting into gas. Then we also took into account the wood energy which is used for cooking but which is bought. Whatever is cut and put on the head load, we did not take into account because that is a part of the Phaltan Taluka energy source. But what is bought in the market, that we took. And then we took also the survey for the diesel and the petrol consumption, because these are the energies which are coming into Phaltan Taluka which have not been produced in Phaltan Taluka.
Based upon this survey and other studies, Anil and his group took upon themselves the following tasks: to carry out needed research and development to meet local energy needs and to raise the standard of living of local people by developing devices for increased convenience of the users, to help in manufacturing of these devices so that they can be easily and cheaply available to rural population, to act as information, education and training centers in cooperation with local population. And the most important of all is to solve the problems of rural energy with the tools of good science and technology.
Anil, based on this survey of energy needs, how did you come to decide about the kind of problems that you should really take up in this institute?
Not only on our own survey, our survey is not a very unique survey. The uniqueness lies that we did once for Taluka. But there are similar surveys which have been done for the rural areas all over India. And our numbers also jived very well with those numbers. And we found out that 90% of all the energy used in rural areas is for cooking and lighting. So that told us that this is the first problem we'll have to attack. Now in cooking and lighting, the lighting energy all over India in rural areas is kerosene. Cooking is wood and kerosene partly. And so we thought that how we are going to produce a fuel which will solve these problems of cooking and lighting. Then the second, so there are only 10% left. Now 5% of the energy, or sometimes 7%, is used for water pumping. So that was the second choice of our problem, to produce a device or produce a technology which will solve the problem of water pumping from the renewable energy sources. And the rest of the energy was for other incidentals like rural industries, etc., etc.
Yeah.
So these were the critical components:
Yes.
cooking and lighting, fuel, and water pump.
I think that was a good choice to find out or do some research work on lighting. Is that the reason why you decided to do research on the lantern?
Yes, in fact, since I live in a rural area, my first impact was that there were a lot of times when there was no electricity, and at night I had to read in that meager light from the hurricane lantern. And when I started reading into that, naturally your mind starts working, because the necessity is the mother invention. And I said to myself that what is this device in whose light am I reading, and can it be improved? And so that was the starting point, where I said that we should be able to improve upon this lantern, and especially the fact that nothing has happened since last 100 years. This is a 1800 design. And so the idea was that what can we do with the modern materials that are available to us. Modern technology is available to us in terms of heat and mass transfer, and all the different things that is available to us.
Thousands of rural households either use chula as light source or a chimney light with open flame, along with all the risks of burning the hut and themselves. With heavy investment made in rural electrification, only 10 to 20% of rural households have been electrified. Thus, a majority of population still uses hurricane lantern, an inefficient and poor source of light. This was the point of entry of Anil and his group to start the research and development in improving existing lanterns. This project has been funded by Advisory Board on Energy.
This is a NARI lantern which is running on ethanol. This lantern has been developed by our laboratory basically to improve on the existing hurricane lantern. Hurricane lantern, as all of you know, is an extremely inefficient device which gives out extremely poor light. The idea was to provide a lantern for rural applications which will give out good light, let's say equivalent to 25-watt bulb. So the development in our laboratory continued on that line, and we wanted to have something which will be like a Petromax lamp, but which will also have all the advantages of hurricane lamp. So what you see here, NARI lantern, is a cross between a hurricane and a Petromax lamp. The hurricane lamp features of this lantern are the ease of use, where we can lift it and take it any place. The wick type system, where we can increase or decrease the light just by the flick of the lever, which is the same in the hurricane lamp. And the Petromax lamp features because the mantle is what gives out the light. The mantle is of the Petromax variety, but it is not a pressurized system. The interesting feature of this is that we have been able to make this lamp very cheap. We believe that we can be able to sell this lamp at 75 rupees, which is twice the price of the hurricane lamp, but which gives out light which is equivalent to almost 4 to 5 times more than the hurricane lamp. Now, we did a lot of very interesting scientific experiments, and we were able to develop this device after quite amount of heat and mass transfer and other experimentation. And I'd like to show you some of the equipment that we used in developing and finding out the light output. In front of me is a Brodom photometer. This photometer tells me, or basically it compares the light of my NARI lantern with that of the bulb. On my right is a bulb which is 25-watt bulb, and I increase the rheostat to 230, and which gives me the 25-watt bulb, the light, and I compare this with my lantern. I can move this left or right such that when I look through this Brodom photometer, both the light signals from this bulb and my lamp merge together. And that is where I find that I am getting light output equivalent to 25-watt bulb. Not only this, we also measured the spectrophotometer of our hurricane lantern with the help of a spectrophotometer, which is in front of me. Here we were able to show what exactly is the spectrum of our mantle and how it differs from the hurricane lamp. Then, at the same time, we were also interested in finding out how can we produce a burner which will give us temperatures exceeding 1000 degrees centigrade. Because of the fact that this mantle can only light above 1000 degrees centigrade. In order to do that, we did a lot of heat and mass transfer, and one of the main ingredients of the heat and mass transfer was the analysis of the flue gases. In order to analyze the flue gases so that we could develop better burner, we used the flue gases and we then injected them into what is called as a gas chromatograph, where we could get the signature of these gases, finding out how much is carbon monoxide, how much is carbon dioxide, and in finding this out, we were able to tell whether our burner was better or poor. In this way, we developed this lamp. And another thing very interesting that we have done is that besides running it on kerosene is another lamp running on alcohol. And this is what I am showing you. The kerosene lamp is also same, except that the chimney is a little longer and the light output is nearly same. The third thing which we have done here is that this lamp is a dual purpose lamp. Besides giving the light output, it can also be used for cooking. And I'll show you the arrangement. This is an arrangement which doubles up both as a lifting arrangement at the same time as something in which you can cook. Here is a small utensil in which we can boil water. And the tests conducted have shown that we can boil 500 milliliters of water in 1 hour in this lamp. So at the same time when it is giving light, we can either boil milk or produce tea. This lamp is very simple in its operation it is as simple as a hurricane lamp. And I'll just show you how to light it and operate it. Right now it is running. We can shut it off by simply reducing the flame and blowing it. Now I'll show you how to light it. We just raise this lever up. Just keep this here. Then I just light this. And I raise and I bring this down. It is as simple as that. There is no pressure. There is no complication of Petromax where you had to put pressurize it and there are 2 or 3 levers. And it is so simple that anybody in the rural areas can operate it because they are already used to operating a hurricane lamp. One very unique feature of this particular NARI lantern is that it is running on alcohol, ethyl alcohol. The whole scenario of India is such that today we are using 60% of total kerosene consumption in India only in lighting, which is equivalent to 3.6 million tons of kerosene every year. It puts an extremely heavy burden on the foreign exchange. We are importing to the tune of 1,000 crores worth of kerosene every year. The idea is that we can produce our own alcohol from different sources and we can run our cooking and lighting for rural areas on alcohol. This alcohol that is used in this lamp has been distilled in our own laboratory from an extremely interesting experiment of solar distillation of alcohol. We have set up Asia's first pilot plant on solar distillation of alcohol, where we are using sweet sorghum or jawar as a raw base, as a raw material, in which we produce the sugar, the juice from sweet sorghum, ferment it and distill it in our pilot plant.
Atul, we are going to give you 3 lamps. Please read in the light of these 3 lamps and let us know which is the best, which is not so good and which is very bad.
With this lantern on, I am not able to read quite properly. I feel that there is some strain on my eyes while I am reading this with this light on. This lantern is much better as I feel because I can read it very clearly now. But the earlier lantern, it was not giving me sufficient light, so I had to keep the book very near to my eyes and now I can read it very clearly.
This is the 3rd lamp, Atul, we have given you. Now make your assessment.
This lantern and the previous lantern are quite similar in their light output as far as I think. This also gives me sufficient light for reading. This is much better than the first lantern which I was using.
How about the comparison between the second and this one? Is there any marked difference?
Well, I can't mark any difference, but I can definitely tell that both the second one and the third one are giving me sufficient light for reading.
At present, the plans are for mass manufacture of these lanterns. The second problem that Anil and his group tackled was of providing convenient fuel for cooking and lighting energy needs of rural India. His energy survey shows that 90% of the total rural energy used is in lighting and cooking. And he came up with an interesting solution to this problem.
Now let me come to the ethanol plant. I think I'm quite excited about it. Can you say something more about this ethanol plant and the future of such ethanol plants in India, rural India?
Well, since we wanted to develop fuel for cooking and lighting, naturally we found out that our survey showed that women who were going and cutting the wood, the moment they got little more money, they started buying the wood. And the moment they got little more money, they started using kerosene. So we felt that the future is in liquid fuel because in terms of high energy density and also in terms of convenience. So we said that we are going to produce a fuel which will be equivalent to kerosene, and the fuel which we felt would do all the job would be ethanol. And this is Asia's first pilot plant
I see.
on solar distillation of ethanol, and third in the world.
I see.
So we are very excited about it.
Yeah.
And the idea behind this plant is to develop a technology for mini distilleries. The idea is that ultimately for taluka, we want to supply all the cooking and lighting energies of the villages by replacing kerosene from ethanol. So for that, we think that the future is for a plant which will be 1,000 to 5,000 liters per day capacity, which will have a first-class chemical engineering technology, which is partially centralized because I can denature the ethanol because I don't want people drinking it, and which will also